Evening all. And yes, I almost fainted. So I've been doing a 72-hour fast, and I'm about 71 hours and 20 minutes into it now, although I have just broke the fast by having some bone broth, because I was having a nice hot shower, and then, yeah, like I suddenly started feeling sick, and then I suddenly started feeling dizzy, and I was like, oh, here we go. And I almost fainted. Claire almost had to catch me. But I'm all good now. It's all fine. Yeah, I thought I'd do a sit-down stream tonight rather than the standing stream, just in case. But I'm sure I'll be fine. That's what happens when you don't eat for 3 days and then have like a scalding hot shower. Hey Diesel, thank you. Actually, I found the fast really easy. Like, going 3 days without eating wasn't a challenge at all. But yeah, that shower just completely knocked me out. Wasn't expecting that. But it means I can get back onto keto now and keep losing weight. Get rid of all the Christmas chub. Anywho, we are going to be making more of the Caravella Class's electrical system tonight. Hopefully it will go smoothly. On the last Sunday stream we had quite a lot of issues to fix. It just goes that way sometimes. But yeah, let's see if we can get more of that actually properly rolled out and start getting that ship powered properly by its own reactor. I want to get the Caravella kind of flyable as soon as possible, really, so it's like a proper usable ship. And then we can roll out things like the sublight flight on the Caravella first. But yeah, so let's see how far we get with it. I've been fixing the YouTube player as well. The YouTube player is, I'd say 99.9% working. We just have one crash now, which is this. For some reason, I don't know what's causing it, but when it goes to get the stream URL from our JSON response, it just crashes. The whole thing just hangs. And I haven't quite worked out why. But as soon as I fix that, then the YouTube player will be 100% working. And we have a lot of extra detail in the JSON package, including things like the thumbnail. So we could actually display the thumbnail image on the player, which is quite cool. And also it's got things like the video description, the channel name, and loads of other stuff, which is kind of useful to put on the UI. So I will grab all of that and display as much data as we can. But yeah, so play works, pause works, loading videos works, and it works perfectly in multiplayer as well. If we can just solve the crashing, it will be perfect. But we want the Caravella. I'm pretty sure it won't do live stream starter. To be fair, I haven't tried, but I'm pretty sure it won't. Yeah, I'm doing an is valid check on it now, and so what I'm doing is when I get the response object, because what we do is we extract the YouTube ID, just like the code, the 10-digit code at the end of the URL, and then we basically just construct a JSON response and send that to Rapid API. So rapidapi.com is like the mediator between YouTube and creating the stream. And when that comes back with a request complete, we grab our response object, which contains like all of the different fields with all the different data. So I'm doing a validity check on that. So as long as those string fields are populated, we should be good. But for some reason, storing the response object in a variable makes all the fields blank for some weird reason. But yeah, I will get to the bottom of it. Because yeah, I moved to using a variable rather than pinning it up like directly. But yeah, so for some reason that's blanking out the fields. We'll see, I'm sure we'll get it fixed. Yeah, having it play in the conference room live would be amazing. I mean, we can try it. Let's, oh, hang on, sort the camera out. Slow down, camera. I'll have to pin that up directly. So it's still going to do the validity check before continuing. So hopefully it won't crash. But if we grab our stream URL, streaming myself. I imagine actually yeah, so the live streams don't have this in it, do they? So it's not going to be able to pass the URL. I wonder if because if we just bypass that a minute and just pop in what is the 10-digit ID without trying to work it out first, see whether that actually plays anything, because that would be interesting. Because if it does, then I'll do multiple parses to see which type of video we're watching. Yeah, technically this should do it. I think we got hit by a potato. So if we just... I guess we'll put in the whole thing. Yeah, it's still coming up with a blank field. Oh, I think it needs to contain the word YouTube. No, not going to work. Not to worry. I shall fix that off of the stream. So what we were doing on the last stream is we were getting this distribution box here working with the reactor by way of overlapping connectors, so that as long as the connector from this cable, i.e. this, is overlapping the connector from the box, then we have an established connection. So the next step in that process was getting the batteries to start accepting a charge. And again, we might need just to duplicate the battery reactor and change how it works slightly, because we're trying this with a pulsed electrical system rather than an event-driven one, to see how well it performs. And then assuming we can get the batteries charged, once these are all outputting voltage, then we'll start doing the per deck distributors, and then ultimately by the end of the stream I'd like to see these lights powered directly by the reactor, or directly by the batteries from the reactor, which would be nice. Because from there it's just a case of just doing the rollout of all the electrical infrastructure, making sure that every corridor has power, every room has power, and everything is good to go. At that point we should have a fully wired ship. Yeah, well, if Elon Musk wants to step in and back the game, I won't turn him down. Right, so I think the point we got to was the UI wasn't turning on for this, but it was powering everything, so we won't worry about the UIs for now, as long as we're getting power. Yeah, then we just need to make sure that we've got some green flashies on here. In fact, let's just double check that. Seem to have plummeted through the floor. Well, it sounds like the reactor's on, so that's good. Right, so we've got output there, which means we should have flashies there. No. Okay, so doesn't help that I'm using the same plug mesh for both sides. Yeah, so that should be flashing green there, and it's not. So for one reason or another, that cable is not transmitting. But it should at least be receiving. Yeah, ignore the ship decor. Let's set up some debugs, I reckon. Right, that should report the voltage if we tick it on, just to see whether it's actually getting any. So turn show debug on for that, and then similarly need to make sure we're actually outputting voltage on the box. Okay, so we're definitely checking for voltage there. Okay, which means right, okay, that's just updating that. Make sure that we've got that working there. Okay. Wondering whether this is returning false. I suppose I'll do a check on. Actually, no, I don't need to with this one. Cable. Found. Hey, Dongo. Okay, so I'm not getting errors from that. Just make sure that we have that ticked for show debug. Yep. Okay, so the fact that that's not spamming any debug text means that it's not getting any kind of transmission from this box. So this box is the problem. So when we start, so where's our downstream cables? Here. So we're not getting an error on that. Make sure that we are in fact identifying 4 cables there. Well, technically 5, because it should identify the input cable as well. One, 2, 3, 4, 5. So it thinks it's sending voltage to the right place. Yes, Delta. So that's all fixed now. The only thing that's not fixed is that when you reload a game or press continue game, what seems to be happening is the data's there as part of the save file, but it doesn't get applied until you press F3. So F3 seems to be fixing the floor material type and the lighting colors. So just press F3 and it's all there. I need to make sure that it's applying that properly on load, because that's the bit that it's not doing right now. Yeah, and when it comes to the Caravella, so we've had a few questions about this recently, as in, you know, when do people get to test it? So obviously right now, it's very much not finished. We need an interior, we need some actual controls, that needs to be a functional holo display, you know, we need all the helm set up there, we need working sensors. So there's a bunch of stuff that needs doing before, you know, we can say, right, here, test it out. You know, not least of which we need the electrical system working properly. Now, as soon as it's flyable, as in you can actually, you know, do a mission with it, at that point, all of our Rear Admiral tier backers get access to it immediately by way of Steam ID. So we'll have a database of Steam IDs and we'll just give access via that. Closer to launch, we will open it up to all backers so that we can stress test it and make sure there are no issues, and just make sure that the ship is ready to go and it's nicely polished. So yeah, so all backers will get access to the Caravella probably at least a month before we're considering it done, if not a couple of months, just to give people time to test it. As for when that is, don't know. It really depends on how quickly the ship comes together, which right now is an unknown factor. Right, so we know that we are definitely identifying a cable. So that is fine. Yeah. Just wondering whether or not we're not sending voltage immediately because this box is not actually running a tick. So because we were doing a tick-based system, when we do our internal bus management, so what we're doing is we are taking the voltage that we've established on all of the inputs, and then whatever the maximum voltage is of all of those voltages, we consider that to be our bus voltage. They're all connected in parallel, so you know, physically, whichever wire has the highest voltage on it is the one that you know, the bus would be using. And we then load balance our wattage across all of those inputs in terms of working out things like amperage on the wire. Yeah, so when we do this, so we know that that's got voltage, and we have that set. So then we run that event. Okay, so let's do some debugging here. So we're sending that voltage to cable, wherever the cable reference is. So plug the voltage in there. We will just get the description of that. Okay, so we're ticking once per second, so let's set the debug to a second so we don't get too many of them. There we, so we should see 4 voltage outputs. Right, I think I know what's happening. So it's doing it once and then just abandoning ship. And I think the reason for that... Let's get rid of this YouTube player stuff a minute. Yeah, the reason for that is on the manage internal bus, we're checking to see whether or not the voltage has changed. Of course, because before it was event driven, so we only sent messages if the voltage has changed. But now, we don't care if the voltage has changed or not, because we're just sending the same voltage again. And the same here. Whereas we don't need to worry about that. So we should get a constant spam now of voltage being sent. No, it's still only doing it once, so it must be doing a breakout somewhere else. Let's get rid of all of this a minute. Right, let's follow the chain of events. Right, so when we have loading complete on the server, we find our cables, we manage our internal bus, and then that should fire every time we receive voltage. Yeah, so there. So we are. So we're doing set with notify. So we've got a rep notify function, and that's just firing internal bus. So this should be firing once per second. Let's just make sure that it is. So that should be the voltage coming in from the reactor, which right now is some crazy amount of voltage. Okay, so the issue is further up the line. I wonder if the reactor is doing the same thing where it's not sending if the voltage hasn't changed. Or the cable. So voltage comes in. We set that. It just sorts the lights out. Yeah, then we're not checking for repeats, so that's fine. Which means it must be the reactor itself. So it's our reactor delivery tick that we want to. So yeah, there. That's the problem right there. So basically, if the interface is not enabled, we're just going to send 0 on our voltage tick. And we'll be making lots of interfaces on the reactor for each of the high voltage outputs. So we'll also need to do step down voltage on this as well. So obviously right now we're sending the entire reactor bus voltage out of the interface, but that's a crazy amount. So we need to step that down to whatever voltage we're using for charging the batteries. Right, let's see. Okay, that's more like it. So okay, we're definitely ticking voltage delivery, but the cable says it's getting 0. So just to see what the cable actually thinks it's getting. Yeah, so still nothing there. Okay, so we know that that is working. So that comes through to here. And then that's sending that, so it must be breaking somewhere along there. So to be perfectly honest, we don't need any of that. We can bypass that entirely. And then just update that. So for each interface, if it's plugged in, then we take our internal bus voltage, work out whether it's enabled and connected. We'll check that, make sure that's not reporting false. Let's just do a couple of debugs here. So internal bus would be that. Yeah, let's just check enabled. And we'll also check connected. So is it enabled? Is it connected? And on this side, yeah, because that was reporting 0. So that needs to not report 0. Okay, so the internal bus reckons it's on 100 million. Enabled true, connected true. So that's what we want to see. So we're losing the voltage somewhere before it hits there. So that must be being 0, which it shouldn't do. So if we were to just put that straight in there and avoid that check, so even though they're both reporting true, let's work out what we're seeing here. So interface 1 voltage. Let's see what that's actually saying. It should say 100 million. So yeah, so interface 1 voltage is reporting 0. Okay, so from here to here, we're losing 100 million volts somewhere. I guess it's this maximum here. Oh, I see. So we've got a maximum of 0. Is that right? I see what's going on. So on the box config here, we are not specifying our step down voltage. So all of these, if we use 240 for now, this is our configured voltage. Of course, we were stepping it down to 0 rather than 240, so that would make sense. There we go. Now we're seeing 240 volts on the cable. So if we run up here, we should start seeing flashies. Yes, we have flashies. Right, okay, so the voltage is reaching this point. So the next step is to get these batteries seeing that cable and accepting that voltage. Yeah, I'm going to work out whether those are the ticking ones or not. Yeah, it is. So we did make a separate class. Yeah. If it tastes like metal, then it's got voltage going through it. Okay, so we know that's working, and that can be the same for all of them. That's fine as is. Means we don't need that debug there. And we don't need that anymore actually, because that was from when it was an event-driven thing. So to make sure that we absolutely definitely send the voltage through, if the cable wasn't valid yet, then we would retry until it was. But that's not needed now because we're pulsing once per second. I should just make that easier. Right, and we had some other debug spam on here that we need to get rid of. So those ones can stay. Get rid of that one. That's the only one to get rid of. And that one can stay. Right, next, let's sort the batteries out. Okay, blah, 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 blah. That's a bunch of UI work. Don't care about that right now. Okay, so we'll find our upstream cable. So we step through those. So I guess the first thing we need to check is, are we getting a load? So we want to see a non-zero value there. Yeah, there we go. So batteries are seeing 240. Did I set Alt 4 to there? No, I really didn't. Okay. I'll move Alt 4 into the battery room. Okay, so again, we've got no screens coming on, but we do have voltage coming into the array. So that bit is good. Just make sure this isn't an optimization thing. No, I bet it is. So our deck check operates on the basis of how far above or below the world origin you are. So we just calculate vertical distance to work out the deck. But obviously on the Caravella, that's completely irrelevant because we've based that on the Magellan. So we need to do a current ship check on that to make sure that we're working out that the player is on the correct deck, depending on the ship. So I'll have to do the same here. For now, I'll just set it to all of the decks. That'll probably fix this UI as well, actually. Huzzah. So that screen fits perfectly. Okay, so we're seeing 240 volts on that one. Not sure why we're not seeing it on the other four. I will check them after. Okay, so only one of them is outputting. That's fine. So, okay, not having any load is normal. We should see some load here. The main issue here is we're not actually we're not sending our wattage reports backwards down the line. So in order to calculate that, we need to work out what wattage the device is using at the end of the line, and then we send that wattage backwards to the distributor, and it takes the sum of those wattages and then works out the amperage for itself on its bus, and then it passes that back down along the line. So it keeps passing the wattage upstream, and you'll find that the amperage kind of drops as it goes, but that's basically how it works. But yeah, so I think what I'll do, if we set them to start empty, because it's obviously it's not starting cold and dark, so it's going to start fully charged. But if we change that behavior a minute, I want to make sure that they are actually charging. Yeah, so we're setting their charge to their capacity, and if we're in cold and dark mode, it sets the charge to 0. So I think what I'll do is we will remove that so that they all start at 0, so we can make sure that they're actually charging. And then we need to work out why we're not seeing voltage on the other 3 interfaces here. I'm wondering whether it's because I haven't copy pasted that down. Oh no, they are correct. Or is it because did I not bypass that? No, was it on the internal bus? I'll work out those other 3 afterwards. Let's just see whether that battery is charging or not. It's the first sign of madness, apparently, binary. Although I think I may have lost it years ago. I've never been particularly good at reading out loud, so I doubt that would go down well. Hey, Jim. Okay, so they're all charging. That's promising. Waiting to see a slither of yellow on the battery readout. I can't remember actually on the Magellan whether or not we were using 1 kilovolts for charging the batteries. I think we actually might have been. Let's try upping that voltage. So basically on this box, change these to 1000. Should technically be charging those batteries quicker then. The batteries and basically everything is going to be the same as the Magellan, only more real time, and we will update the Magellan to this new system, assuming that it works smoothly. That's better, yeah. So we're charging at 5 amps now rather than 1.5. I'm not sure at what point we have a UI readout. Oh, there we go. We have a slither of yellow. Okay, so they are definitely charging, which means we should technically have some sign of life there. Yeah, at the moment it's fairly like self-managed. I guess in the future it would be nice to include the ability to break stuff by overcharging and overvolting. Oh, I put my water all the way over there. Hang on. Why did I leave it over there? But yeah, so in the future it would be nice to have the ability for things to break and burn out, and in an emergency situation it would be nice to be able to turn up the power to be able to get a short-term benefit at the risk of breaking things. Well, that's the first fizzy water I've had in like 3 days. My insides were not expecting that. I forgot to mention actually, after the yeah, it is Claire, definitely. After the last stream, where we were building these storage shelves for samples, I just tried out connecting the bases together on them, and they look so much nicer in game having like a solid front. So we'll still have like circular, I guess, attachment points for the containers so they don't fall off, but having them joined like that just looks better than having them like this. Yeah. Do that one. It's almost too fizzy. So the cables that we're missing right now is we need a cable that goes, I guess, from the distribution boxes although I guess these are aggregators, aren't they? Yeah, because these are the per deck distribution boxes. And these are charging things like the doors and stuff, and the shield that goes up over the doors. So we need a couple of cables just to connect those up. let's do the back wall. Yeah, so we've got that sloping back to the room, like that. So I think rather than having the sloping back to it, let's just square it off and just have that as framework. And to be honest, we can have that as armor plating at the back there. Given that this is the battery room, we will reinforce the back of the ship here. So let's do it literally from there. So that's 1, 2, 3, 4, 5, 6, 7, 8. So deck 1, framework walls, segment 8. Okay, gives us our back wall. Then we just need to do the actual ceiling part, because obviously we've got no ceiling right now. But that gives us an idea of where we need the cables to run to and where those two aggregators need to be. So there's going to be one either side, which I guess we could put on the back wall. Yeah, well, actually, I'll put the aggregators on the back wall, and then we'll have these cables come up and over. So I suppose on that note, let's make some different battery meshes, and just make sure that these ones are not using some weird origin point. That seems to be okay. It does, however, include the screen. I'll redo that for this ship. I used to use Blender for some intermediary steps, modeling wise, but then Unreal does that stuff now itself, so I've not had a need to go into Blender for anything. Things like face weighting normals and that sort of thing. Okay, so I want to evenly space these out and make those arrays both taller and longer. So we'll have the the actual battery array units go practically all the way to the ceiling. Maybe drop them down 50. Oh yeah, the cable. So right now, you'll notice that when we've been planning the cables out, I'm literally just roughing out some cable locations. They will all connect seamlessly eventually, but for now this is just roughing out where things are going, because we need to obviously position the distribution box on the wall, work out exactly where the interface is coming in, where the input plug will be, and then model the cable to align with that. And then we need to make sure that they are positioned in the world in the right place. But until then, we'll have them just flapping around. So like these boxes here, I'll move those onto the back wall, because the back wall's not being used for anything right now, so we may as well. Pop that on there. Might as well just copy it to there. So each one of those will take inputs from 2 battery arrays. So basically we've got port and starboard. So each side of the ship is powered by 2 battery arrays. So if we measure that, it's difficult to get the gap right between things. So if I were to measure it like that, and then we align each ray to the 4 points, then the gap between each array is smaller than the gap to the wall. So I guess we need to take the width of the array away from the wall and measure it from there, but then that changes the width of the array, so it's kind of an annoying process. So I guess if we were to align that to that and align that to that, then the midpoint, no, I guess the midpoint would be there, wouldn't it? So align that to that, that to that, that to that, that to that. Yeah, so they have equal gaps between each other, but now we've got the wrong gap to the wall. So yeah, I always find that a bit of a head scratcher, getting that equally spaced out. Out of interest, what is that gap? 94 there, and 200 to there. So in an ideal world, we kind of want to have about, I don't know, 163 even to that wall. Yeah, we want to have about 1.5 meters clearance for the NPCs. So if we were to say 150 to there. Actually, let's be even more precise, because we've got a 5 centimeter gap for the support that goes down vertically, and then we've got another probably about another 5 centimeters for a wall panel. So we're probably measuring it really from there. So our 1.5 meters is that far from the wall. And the same on this side, so 150 plus the 2 5s, yeah, it's 160. So that one would have to be there. Okay, so both of them should be 160, yep. So the question then becomes, is how big are the actual battery units in the array? Now we know we've got 5 on each side. That was 5, wasn't it? Yeah. Because what these have never had is the actual battery units in them. So the idea that these were the containers for the batteries, but we'll make them much bigger and taller. We could potentially fit 2 units in the room, so we could actually have 4 batteries per side of the ship, because this room is big enough for that. Okay, so if we work out how big one of those should be, let's grab our dude for scale. Yeah, it's a breeze really to work in SketchUp. Just export the FBX from here, and then you do the texturing and UV mapping in Unreal. The only thing I export from SketchUp is literally the geometry itself, and then the texture groups. Just those 2 things are what's needed. So if we say that a battery is about 80 centimeters tall, just thinking in terms of actually carrying them around, then maybe 40 wide. So in terms of something that can be realistically carried by a crew member, because ultimately we do want to be able to print them out and replace them, they need to be big, but not so big that they're unwieldy. We can potentially double stack them, but the issue there is UI space, because obviously we've only really got room on the UI for 10 battery arrays, which is a bit of a pain. But I suppose if we double stack the units, then we can just have 2 UIs. Yeah, silent running mode. I guess so, but the amount of energy needed for things like the main engines, you're talking probably more than this battery array can output, unless we can slow charge some capacitors and then use those capacitors for the engines. But then I guess turning the reactor down to practically zero is pretty much silent running anyway. I mean, yes, you're still initiating a fusion reaction, but you're using very little in the way of fuel, and the output wouldn't be great. Because if you're only powering the sublight engines, or even just powering the RCS thrusters, you're not going to need a huge amount of power. Certainly not the kind of power you need for the FTL. So the idea is that most of the time, the reactor is not going to be set to 100%. You only need to turn it up to initiate the FTL, or to power the weapons and the shields and that sort of thing. When you're not in combat and you're not at FTL, you'll need to turn the reactor down, otherwise you're burning out components and using way more fuel than you'd otherwise need to use, because you're just venting the excess plasma into space, because the electrical generation is kind of a zero-sum game. That energy has to go somewhere. So if you're not using the energy that the reactor's generating, then just venting it out as charged plasma is all you can do. These batteries are solid-state batteries. We haven't decided what they're made of yet, but something like carbon nanotubes or something like that. I mean, weight-wise, they just need to be manageable. But yeah, so if we were to assume something of that nature. And then we separate them by, say, I don't know, 10 centimeters or so. Okay, then that would be our 5 on one side of the array. And I guess the arrays don't need to be super big. They just need a common bus going down the middle. So if we maybe do the same, to be honest, have them at a 10 centimeter gap. So if that was a 1 10-cell array, then there's way more room in this room than we actually need for that. So we could have them potentially back to back. Let's group these up a minute. Slightly raised off the floor. Because one of my issues with the battery rooms on the Magellan is they just don't look like enough. They're just, you feel that there should be way more than that. And I'm wondering whether the same is true here. Whereas, given that we're powering the whole ship from these batteries, we need enough batteries in order to do that. Although, that said, it's only really the internal ship systems that are using the batteries. So weapons are straight off the reactor, shields are straight off the reactor, the main engines are straight off the reactor. So it's only going to be the sublight thrusters and internal ship systems that are actually using the batteries. So it's nothing super high voltage. Ah, 300 kg, that's not too bad, surely. It's only 3 of me. Yeah, so the alternative would be to do away with the idea of individual cells and just have giant batteries that are made up of cells but have a single UI on them. But that kind of removes the replaceability aspect of it. Or rather than having individual cells like we do here, and like on the UI we show a charge level, an amperage and such for each cell individually. What we could do instead is maybe show the overall capacity for the entire battery block, and just treat each one of those cells as additional capacity. So if one of those cells breaks, you just see a drop in overall capacity in the battery, and we handle it that way. So we're not having to worry about fitting, say, 30, 40 battery cells onto UI. We could do it that way. In which case we could make this a lot more substantial, with a lot more stuff. And again, we also need to do the energy density calculation. Now let's just Google that a minute. Energy density of a battery. So lithium ion. So around a capacity, maximum capacity of about 260 watt hours per kilogram. So we will improve upon that. Obviously we're using some kind of carbon nanotube solid state arrangement for our battery cells. So we will improve upon lithium ion, but it's going to be around about that ballpark. So if we were to say 500 watt hours per kilogram, that's twice the capacity of lithium ion. Then we'll work out what the volume of that is for our battery arrays. Because ultimately we want the capacity to the storage to be relevant. Yeah, I'll have to Google it and work out what the best thing is. Obviously we want a futurized version of whatever that may be. So if we were to stack them on top of each other with a gap, yeah, so I think that's fine height-wise. Yeah, they pretty much do. So, other than the RCS, I think the RCS is probably going to be the most voltage drawing thing, but they'll work with capacitors, so they'll have their own capacitors. So the idea is that the capacitors charge off of the batteries, and And the idea there is, if the reactor's offline, then you've still got some maneuverability in the ship. You might not be able to go anywhere, but yeah, you can at least maneuver at basic RCS speeds. We also have to think about how we go about maneuvering the ship to a gas giant if the reactor fails. So if you run out of fuel, so you're now stranded, the nearest gas giant might be, I don't know, 20 AU away. You're not going to fly 20 AU at sublight speeds because that's going to take months. So you need some way of jumping in short hops with the FTL drive. So the idea is that you use your batteries to charge up the FTL capacitors. So the FTL capacitors can power the FTL drive for a very short period of time. So it might take you 3 or 4 hops, but you can get to that gas giant and then refuel the ship. And we would use the batteries for that. So they'd need to hold enough energy to be able to briefly charge the FTL drive as well. But again, it's the capacitors that are doing the work, not the batteries. They're just charging the capacitors up. Yeah. I mean, if you run out of fuel, we want it to be painful, but not like unrecoverable. So if you can at least use your battery charge to drag your way to a gas giant, at least then you can refuel, start the reactor, and carry on your way. If your batteries are then dead and you've got no fuel, then that would be a game over scenario. You've basically left yourself stranded with no energy. Although, yes, the ship will have solar sails, well, solar arrays. So you will be able to charge the batteries from the solar array, assuming you are within range of a star. So there will be multiple ways of recovering from such situations. And we'll also have maybe reactors on the shuttles, because I kind of like the idea of plugging a shuttle into the ship so that you can charge the batteries from the shuttle's reactor. But I think the smaller shuttles aren't big enough for a reactor, so they'll just have their own batteries. So you charge the shuttles on the ship, do whatever mission you're doing on them, but then you have to recharge them each time. But yeah, maybe the bigger shuttles can have reactors. Yeah, the fusion uses deuterium and helium-3. It's as close to aneutronic as we're going to get. Yeah, so we could bulk this out a bit and just have a long set of battery cells as part of one big unit. Obviously make it a bit chunkier, make it a bit more sci-fi looking, and those would be our battery units. So if we were to group them up a minute. Have a good one, PSV. Yes, absolutely. So the ship does have a fuel scoop, and gas giants are the source of choice. So you're not having to risk diving into the corona of a star. Gas giants have plenty of gas around them that you can scoop up. Okay, so that looks a bit more reasonable in terms of battery storage. And then we need, obviously, the input and output ports on the arrays. Yeah, we'll have differing degrees of chemicals per gas giant. So obviously some gas giants will be better than others for scooping. But yeah, ultimately, practically every star system will be scoopable, regardless of what type of star it is, because we're scooping gas giant atmospheres directly. And, you know, I want this kind of cinematic thing where the ship is basically bouncing off of the upper atmosphere layers. So you're like literally flying through the upper clouds of a gas giant. So, you know, we want to see atmospheric effects and, you know, like plasma glow around the ship because it's heating up, you know, around the ship. And yeah, we want it to be like a visually impressive thing. But yeah, gas giants should be huge and impressive. So having to scoop from them gives you a, you know, a good reason to go down and see one in person. I'm a huge fan of Stargate Universe, and I'm not shy about the fact the Destiny is my favourite ship in all of sci-fi. Potentially, yeah. I think Stargate Universe for some reason gets a bad rap, but I kind of like it. I've always found the idea of being stuck on an alien vessel appealing, and that's why I will be building an expansion based on that very concept. Do I have a usable midline? No, I don't. Let's make one. Right, so that's exactly in the middle. Okay, so we'll widen that up a bit. We'll have the UIs, I guess, at this end, and then we'll have the distributors at this end. Sorry, the aggregators at this end. And we'll pop them somewhere between each array, like that. and then both of these ones will plug into that one, these two will plug into that one, and then all of these output cables will go that side and that side, and then we'll have these ones, and we'll have to come up and over. Yeah, because we've got cables in coming from there, and then, oops, stuck in the middle of something. Yeah, then cables out down the other side. So yeah, the port side's going to be easier because we don't have those additional cables coming in. I mean, for redundancy purposes, we could potentially split that out so that we have half and half. Because right now we've got all 4 cables coming in up on this side, on the starboard side. If I was to do the other 2 on the port side, that means we'd have I mean, to be honest, we could probably remove the need for a box there at all, but we would need to add that to the Reactor UI. Because right now, the basically the end cap of the reactor is where all of the voltage comes out of. So it's going to have multiple ports with lots of cables coming out, going their various ways. So, in terms of a centralized management solution, which we'll probably do in here somewhere, we need one central location where you can get like a high-level overview of everything on the power grid. So having a separate distribution box at least gives you some visible oversight on what voltage is going where in terms of distribution to the arrays. So having one on the other side as well is probably like making that a little bit too granular. I don't know, we'll see. I'm going to have to obviously bridge some of these cables over the other cables. It's going to get quite busy up and down this stairwell with cables going up and down all over the place. Yeah, as Claire says, I do pretty much wing it. So I'll have an idea in my head for a ship, and I'll kind of have a rough idea of what I want it to look like. But then, yeah, ultimately I'll just wing it and just see what feels right at the time. Like this particular ship isn't modeled on anything. It's just something that I came up with. I don't think there are any ships in sci-fi that look like this. At least none that I've seen. So yeah, it's just something I'm inventing as I go along. The Magellan class is actually based on a building. This is really cool, like marine center somewhere in China that has like a starship shaped building, and I thought that would be quite a cool shape for the Magellan, so I went with it. For our military vessel, I'm a huge fan of Star Destroyers, so it's probably going to be triangular in theme, but obviously not a Star Destroyer, but triangular shaped-ish. So I generally have a rough idea of what shapes I'm going with. Yeah, battery rooms tend to look like that. Well, case in point. There is a real-world battery room. Yes. They kind of are what they are, aren't they? They're just rooms full of batteries. There's not a lot you can do with a room full of batteries to make it look anything like anything other than a room full of batteries. Yeah, I guess ours is going to look something like that. So we'll have our racks with battery cells on them, obviously sci-fied up a bit, and then we'll just have our aggregators on the walls. I don't think there are really any examples that don't look basically like that. Yeah, or like that one. This one's probably the most sci-fi looking, and again very similar to what we're doing. I think Try Out for Energy posted a picture of their capacitor banks for their fusion reactor, and that looks kind of cool. I think it was Try Out for Energy. I'll have to find that again at some point. This is apparently on a boat. An electric powered boat with 5,000 batteries. I like the inclusion of the blue LEDs. I think we'll have to borrow that idea. But yeah, you know, a battery room is a battery room. Probably not Puntloos, no. Because as much as, yes, you could build it, as you can probably see from the complexity of everything, importing it wouldn't work, because you also need to build all of the ship systems and get all those ship systems working and connected together. And something I'm doing with the Caravella is attempting to make that job easier by having things like overlap checks on plugs, because otherwise we have to manually type in like interface IDs and things. So simply by having them line up should be sufficient. But like, you wouldn't be able to do this in Blender. You've got to do it within Unreal Engine as part of the level file. And not just that, but like every single wall panel is a separate object, and it has health values. It has, you know, the ability to undo the screws and take it off. There's a tremendous amount of internal complexity within the ships that you couldn't just build this in Blender and export it. It's just made up of so many pieces, like thousands and thousands of pieces. Yeah, so my point for kind of roughing in these is I think we'll go with an overall battery unit, which is much bigger and longer with many, many cells, compared to what the Magellan has right now. But we will rebuild the Magellan ones and make them bigger and more impressive. And then we'll treat each unit as a single large combined battery, which is the sum of its arrays. So in terms of capacity, that's going to be dependent on the health of each individual array, so each cell rather. So we'll take the sum capacity of all cells and we will adjust the battery capacity accordingly. That's probably the easiest way of doing it. And it shouldn't matter too much from a programming perspective, because we can just keep adding more and more cells as needed. Although, that said, like when you look at this, so these are the individual cells. So right now that's the 10 cells. If we up that to say 40 or 50 cells, then I think we're going to have to manage this better. Maybe make a struct with all the values and then just loop through the struct array rather than doing each one separately like this. So I think efficiency will be the name of the game with that. But that does make more practical sense for powering a ship from batteries like this. I think we just need the bulk, and we need lots of arrays, and we need the room to be like just full of wires and cables, and it needs to look like a battery room. We will use, so to answer both your question, Cloud and Anasi, the sum charge of the battery array is going to be the sum charge of all of its cells. So if you take out a cell, then the available charge will go down -1 cell. Similarly, if you upgrade a cell and say that that cell has some alien tech now, which is twice as good, then that cell provides more overall energy to the whole array. Good question, Ziza. Yeah, I don't know actually. Probably per array. So yeah, we might need to pipe some liquid helium through this just to keep it all cool. But then again, they are solid state batteries, so I can't see them getting that hot. Right now, CSI, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that's what? So 36, 60, 72, is that? There's about 72 cells there. But when it comes to the simulation of this, again, there's a line we need to draw in the sand as to how much we simulate this. So we're not going to simulate voltage change based on capacity or draw. So the battery array will have a set output voltage, and it will maintain that voltage until all the batteries are dead. Until all the cells are dead, rather. So the level of simulation kind of stops there. So we don't want to go too deep into that, because it's that thing. You could go deeper and you could simulate more, and you could simulate voltage drop off with capacity drop off, but that's probably just a layer too far. Yeah, as for how much power the whole room can provide, we'll have to see. So that's the kind of thing that that we'll tune, because obviously we need to look at how much power the whole ship needs just to run, and then how much additional power we need for emergency situations, like if we're having to like bump start the FTL drive or bump start the reactor. You know, how much extra power do we need to be storing for those things above and beyond what the ship is just using naturally? So we will tune the capacity of the room based on what the ship actually needs when it's finished. Fox, yeah. So the battery array is basically all of these battery cells, which are individual batteries, that you plug into the array. So each one, if we assume they're all connected in parallel, each one will add its capacity to the overall array. If you take one out, then you've removed capacity from the array by the sum of one battery cell. So if these get damaged, then obviously the more damaged each cell is, the less it's contributing to the overall sum of available power. Yeah, that's something we can definitely look into. I think having to really hit the batteries hard to, again, like jumpstart the FTL drive, should have some kind of cause and effect associated with it. But again, that's probably a bit further down the line from where we are right now. Right now, we just need to refine the physical model of the batteries so that we have the right number of cells and it's outputting the right number of power. And then again, as part of the iterative development process, we can then start folding in additional features, you know, on top of that once it's been play tested a little bit. But for now, let's move these along a little bit. Okay, so if each of these is going up and over the ceiling, then I suppose we need to stagger them a little bit. Again, it would be easier to route if we had the other two on the other side. I'm wondering whether or not we take two of them and just cross them over the back wall and up, so they can still be connected to the same distribution box. We're just routing them separately. I mean, they could go behind the cargo lift there. We'll see. We'll see how much room we've actually got. I suppose equally they could just go up and over from this side and around. But we'll see. So we just kind of stagger them like that. We'll have these hanging down on cable trays. So, yeah, we'll input from there. Why is that one not lined up? And then we'll just drop these down from the ceiling to supply the array. One there, one there, one there, and one there. Okay, there we go. So that's going to be the basic cable arrangement. Obviously we will model that properly once we're absolutely definitely set on their positioning. Yeah, so if those ones going in there, and then we'll have the output ones going one there, one there, one there, one there, and that will loop around both sides, and then we'll loop these ones over the top of those ones, and I guess the same coming down. So we'll need to build cable trays for all of these, or at least brackets to hold them up. And I guess we'll route these ones up over the ceiling as well to these boxes. So it's the general idea is we want this room to feel very heavy on the cabling side of things. What with it being a battery room and all. Oh, good night, Jim, and good night, CSI, as well. Have a good one, both. There's only one blocker left, AJ, which is the YouTube player. So as soon as that's not crashing, then we're done with all the blockers. So once all the blockers are out the way, I will then get back to just polishing off the features for 227. And then short of just polishing off a few more of the minor bugs, I think we're good for release at that point. The only thing I need to do for VR is make some kind of like wrist menu for changing the graphics options and for like quitting the game and that sort of thing. So I'll just take the existing pause menu that we have and then just like put it on your wrist for when you're in VR. Just as a for now solution. Right, let's export these a minute so that we can see them like where they are actually in engine. So electrical cables, supply 1. Supply 2. Supply 3. And supply 4. Okay, so if we just grab each one in turn, get the mesh, re-import, save. Next one, get the mesh, re-import, save. And so on and so on. So that's where they're going. We'll move these into position when they have their own meshes. Yeah, so from a walking around the room perspective, you'll be surrounded by lots of cabling, which is very nice. It looks a lot smaller in person than it does like looking at it in SketchUp. Oh, Sophie, thank you. Very much appreciated. Potentially a NASI. We'll see how we go time-wise. Ultimately, a radial menu is not difficult, but it's just dependent on time. We kind of need to get it out and move on to other things. Yeah, so we shall see. Right, okay, so I suppose the next point actually is we need to start drawing on the voltage we've got here. Oh, and let's figure out why the other ones are not coming on. So we were definitely seeing four lots of output on here. So I guess the question there then is if we turn show debug on these. Make sure they're actually getting voltage. So we'll just pop that there real quick. Make it a color that stands out from the rest. So we should see 4 lots of salmon colored voltage. Okay, so that's good. So all of them are getting 1,000. So I suppose the next question then is, are all 4 of them actually outputting that? So yes on that one, yes on that one, and that one, and that one. So that begs the question, why is only one of them working? Oh, I think I know why. It'll be because I didn't set these to the right decks. Yeah, that'll be why. That'll fix that. So now that we know that that's working, we need our output cables going to our aggregators. So I guess we'll just use our existing aggregators for now. And on there, on there. And we'll have them fed from the top. So the cables are going to go up, over, and down into the top of each box. Which means we need to make it dynamically scaled, so that we can position things properly. So the distributors we have, sorry, the aggregators we have on the Magellan, they feed a deck distributor, which we don't necessarily want. So this one's going to have a slightly different layout wiring wise, because the distributors here are going straight to what would be the equivalent of the quadrant distributors on the Magellan. It's a smaller ship, so it doesn't need quite as much of a collapsing of grids. So we can power these directly. So rather than a single output, these ones are going to have multiple outputs. So yes, we need at least 4 for those. Need a 5th one for the doors down there. And then yeah, we've got these ones over here as well. So yeah, so these aggregators are actually going to have a lot of output, unless we do maybe just put a distribution box somewhere in here, maybe on the wall here, as an intermediary. It might be like an unnecessary additional box, but we'll see how it works efficiency wise, because if too many outputs are needed on here, we might need to split that up a bit, but we'll see. Before I delve into that though, I'm going to take a quick 2-minute break because I need a wee-wee, and having like a 3-day water fast makes you wee a lot, like 4 or 5 times a day, a lot. It's crazy. So I shall be right back. Oh, I haven't used my be right back button for ages. Where is it? There it is. Right, back in a minute. I'm back. Yeah, the worst thing about having an office in the garden is that you have to walk through the rain to go to the toilet. Nightmare. Especially when it's cold as well. Thanks, Firstus. We have like a soakaway behind the office, because when I eventually get the sink plumbed in, that's basically where the water will go when I like make tea and coffee and stuff. And my stepdaughter Kate keeps suggesting that I just use it to go and pee outside, but I can't bring myself to do it. I have standards. Oh, very much the basest, yes. So we'll group those up. Group those up. So the idea is that each of these individual cables, along with its cable tray and everything else, will be one static mesh. We'll have separate static meshes for the end caps that will do the overlapping, but the actual thing itself, with all the ties, the brackets, the any labels and coloration that are needed on it, are all going to be part of the same static mesh, so that we don't need to route it via splines or anything like that, and it will load quicker because it's just a static mesh rather than having to do a spline mesh or anything like that. Right, so if those are the battery outputs going into the aggregators, then we shall need to call them something like that. So battery 1, isn't it? So that's actually battery. No, let's not rename that one. Battery output 1. battery output 2. And so on and so on. I'll start changing the colors of these so that we are starting to track differing voltages based on cable color. So we'll make this one slightly lighter for now. I'll probably make a different color entirely. But that'll do for now. Assuming it saves at any point. And we will use the nanite generated collisions for those. Hey, Danger Mouse. All good, thank you. I did almost faint in the shower earlier, but other than that, I am peachy. So that's them. And of course we need to move our input and output ports on those. So interface out needs to go and collide with one of those. And the same with this one. needs to go up and collide with one of those. That's 4, so the next one down. So again, we're basically just overlapping those two plugs in order to ascertain which cable is plugged in where. Which means that the only thing that's important position-wise is the plugs on the end. So that's those ones. So that will overlap there. That will overlap there. That's that half done, and then we need the input, which needs to overlap with the output of the battery, exactly like that, funnily enough. Fortunately, they actually do snap, which is very nice. Right, if we grab a copy of that, then for each one we can at least start off in the right place. So that one snaps to that one. That one snaps to that one. And then that one snaps to that one. Okay, so that should put voltage on those cables. Obviously the actual meshes need to be built up and moved and actually put over here properly. And I might move them forward a bit so there's slightly more room behind here. But as a general idea, that's basically where it will be. It's definitely going to be cramped. But I like that it's going to be cramped because it's a small ship. So it shouldn't be open and airy in these engineering spaces. It should sort of be cramped and tight and difficult to work in. Did I? I'll find out in a minute. So let's take the debug off of these ones because we know these ones are all working. And I shall add it on to these ones, which they've already got, so that's fine. Looks like I broke that one too. Okay. Did I? these things tend to happen. Right, so that is getting voltage, so the one that I didn't break is working, which is nice. So we are on the cusp of powering on that. Right, let's just double check these then. So that one should go there, that one should go there, that one. Oh, I see. Right. So that one. Hang on, let's copy that one. That one, that one, that one, that one. They are still good. So that one's there, that one's there, that one's there, and that one is there. Okay, and just to be sure that they're all visible from the right decks. Right, so they should all be powered on now. And that one's there, that one's there, that one, oh I see, is not where it should be. There, and that one's there. Right, okay. All good. And then we need to check our deck visibility on this one. Again, we need to just make it visible from everywhere until we sort out the specific deck visibility for this ship. I guess it depends. These are the output breakers. Or rather, they're the aggregators, so they are combining the power. Right, so just be sure that those are flashing. Reactor's on. Okay, we have 4 working battery arrays. Nothing there, nothing there. Well, that was working before, so that's weird. Let's check that they're actually charging. Yeah, we've got voltage there, there, and there, and there. Nothing on these cables. Should definitely connect it. Let's just change the mesh on that a minute, because the in interface should be using the male connector, not the female connector. And then this one should be flashing. So yeah, so that's doing the overlap check. That's just cull distances. Okay, so if the bus voltage is greater than 0, then we should be flashing. Okay. Oh. Hang on a minute. Okay, so it's only actually doing the error lights, not the green lights? Yeah. Oh no, that's the test, we don't want that. Ah, this is just... Yeah, so we're not actually doing any of that. So I'll just put that there a minute. Need to come and tidy this up at some point. So that should... Yeah, so that will change the color based on the condition. So if it's not connected, as in there's an error, then X being 1, that would be the red channel. So 1 red, 0 green, 0 blue, so that makes it red. That will make it yellow, that will make it green, and that will make it orangey. Why are we doing that? Weird. Okay. So yeah, we need to check those cables and check the output voltage actually on here. A 1000. Yeah, so they should be receiving 1000 volts, and this will step down. Well, actually, unless we're using this directly, in which case it goes down to 240 anyway. Let's just see what they're reporting. Yeah, just sacrifice some NPCs. That's what they're there for. So we're showing an output there and there. So all of these are showing an input and an output, which is good. But we're not seeing anything on the cables, which is interesting. So why are they not getting a voltage? That is the next step in the puzzle. So it's definitely connected onto that, and that's definitely connected there. May as well snap these while we're at it. Okay. So they are saying they're getting 1,000 volts, which they shouldn't do if the battery arrays are outputting 240. Although not all of them are, which doesn't help. Right, so are all 4 of them showing 240? There isn't a load requirement. If there's no load, it'll just flash with no load. Okay, yeah, they're still saying 1,000 volts. So where are they getting that from? I mean, these should not be showing any debug. Oh, am I not even checking for debug being enabled? That might explain what I'm seeing. Oh yeah, that doesn't help, does it? Those are the only ones we care about. Right, which means that these other cables are not showing any voltage at all. So I suspect it might be a similar issue whereby it's checking to see whether the variable has changed, and if not, then it's not outputting anything, would be my guess. Yeah, that's exactly what it is actually. So we actually want to take the output bus voltage, stick it straight on the wire and skip that, although I suppose we will set that just in case it's needed somewhere else. I'll go back and double check. Yeah. That should stop it from skipping. Okay, so we're not seeing 2 lots of 240, so that means we're not outputting anything. So the question is, does the battery think it is? Actually, let's make this a text one. battery sending this many volts. So there should be 4 batteries sending 240 volts once per second. Okay, sending 0 volts, that's the problem. Oh no, sending 240. Okay, so we are sending 240 volts. Okay. Oh, of course, it'd start off at 0, wouldn't it? Because it wasn't charged yet. Right, so we know that it's trying to send the right voltage. So I wonder if that isn't working. So we're looking for the cable there, setting that there. That's not needed anymore. Let's make sure that that's enabled and stuff. Okay. Let's just do a validity check on this a minute. Make sure they've actually got valid cables to send down to. It doesn't either, no, it starts from scratch each time. Right, so all the battery arrays are saying the cable is false, which means that either the overlap is failing, well, I guess it must be the overlap's failing. Okay, so why is the overlap failing? So that's definitely enabled by default. BP cable tickable. Let's just make sure that this is all set up properly. So they're both set to block all, which is fine. Was it that wasn't working? I remember having to do that differently on the cables, was it? Oh yeah, it was that. Right. Yeah, so that doesn't work. And I made a useful macro for this, so yeah, that one. Let's just copy that a minute. We shall borrow that. So cable tickable, static, blah blah blah. Yeah, that should do what we want. So rather than doing that, oh, it's done that thing where like you can't press delete and you can't select delete from there, and the only way to make it work, like if you compile and save, like you still can't delete, but if you press play, and now you quit. You still can't delete. Hang on, playing and quitting normally fixes it. Okay, now we can delete it. Like, why? Why does playing in editor like allow you to then delete it? It's weird. It is indeed madness, I say. Okay, blah blah blah. What's this one? Downstream, so that's our output interface. Pop that in there. Don't need any of that. Then we can just pop that on there. Huzzah! I'll do the same here as well. So if enabled is true, do the do. Interface in and set the cable. Right. Let's condensed that nicely. Right, so they should be finding their relative cables now. There we go. Now we're seeing some 240 volts. So the screens for the aggregators should now be on. Although we are showing voltage on there now. Okay, so the voltage is getting that far. And it's coming from all 4 of our battery arrays. So I'm wondering whether or not those are actually... Oh no, they're definitely input connectors because they're male. Right, let's figure out what's going on with this then. Okay, so... yeah, so this is just a child class of this one down here. So we know that we've already set this up to do all the overlaps and everything. Yeah, so there's nothing that we're doing here other than just setting up the location of the connectors. I mean, these should all be set as they are in the parent class. So collision wise, they should all be block all and world static. And I'm assuming that's how they're configured here, because they should be. Nope. Okay, so block all, world static. So ultimately, everything the aggregator's doing is the same as this. So we have a certain number of ports in and a certain number of ports out. The only difference between the aggregator and the distributor is we have multiple inputs and a single output, which is why we're calling it an aggregator, as opposed to a distributor where you have a single input and multiple outputs. But in terms of the background code, the box is the same. So let's go ahead and do some debug spam on this. So again, we want a variable for that. So show debug. If that is true, then we just want to get a copy of the voltage. Otherwise, carry on as normal. And then while we're at it, we'll remove the debug from here. Don't need that anymore. And we don't need it on the cable. Where are we? There we are. Okay. So let's just see whether or not those boxes are getting anything. And of course they won't be, because I forgot to tell them to show debug. Debug on that one, and show debug on that one. The screens basically leach voltage from the incoming cable. See, I'm not seeing any debug on there, so that must mean that they're not actually getting any incoming voltage. But yeah, so as long as the input cable, in this case, has some kind of voltage on it, then the voltage for to turn the screen on is taken from that before it reaches the internal bus. So it's basically leaching that incoming voltage just to display the UI. And we'll probably give them at some point their own internal battery, so that they can keep the screen on for a period of time, and obviously that battery is just charged by the input voltage. Well, at some point I want them to be openable, So the idea is that these units, you can take the cover off and see the actual physical bus, the electrical bus on the inside. So you'll see like the bus bar arrangement, and the PCB would be on the back of the screen. But yeah, so yes, basically. So on these cables then, I guess we need to know, like, are they actually getting a reference to the connector? Oh, I wonder if it's a class awareness thing. So obviously we're overlapping distributor master. Do we also need to overlap? Oh, hang on a minute. Hang on a minute. I know what's going on. So this aggregator is obviously inheriting from the original distributor code, which we don't want because these ones are operating slightly differently. So we need to make it a child of the other one instead. So if we go into our electrical system, distributors, yeah, so this aggregator, we actually need a duplicate of that. If we call that one tickable, and then we will reparent this to the tickable version of that. So distribute tickable. Right. So then hopefully, now that it inherits from the class that the cable is looking for, i.e. that one, hopefully because it's a child of that, it should still return as a match. If not, we'll have to add it to the list. Let's just give it, oh no, let's actually add them to the world, shall we? That would help, wouldn't it? So aggregator tickable, and we wanted to make that dynamically scaled, which means it needs to be moved. Right, and then we'll just line that up with the plugs. Like that. And again, on both of those, we'll need to set the deck visibility. Going down as far as F should do it. Right, take that one to G. Can we delete that? No. That'll do. And we also wanted debug, didn't we, on those as well? Right, so if the cables can't find them, as would seem to be the case, then I guess I do need to add that class to our list of matching classes. So distributor aggregator tickable. Okay. Okay, so why aren't they connecting? Oh, actually, that's a good point. I need to disconnect those. Because we're only actually taking voltage in on A and B, which is these two, A and B. Yeah, not the others. So we don't want any downstream cables plugged in yet. Yeah, so I'll unplug those. Make sure those are the right ones. Yeah, so all of the electrical hardware on the Caravella, we're going to experiment with having it, basically the whole network will pulse once a second, because it makes managing it easier and generating faults easier. So if you've got a fault condition on a cable, then every time the voltage tries to pass over that cable once per second, then we can fire off some sparks and cause some effects, because that's constantly, you've got the voltage there that's trying to pass over the cable. With an event-driven system where nothing changes on the network unless something upstream changes, like if the upstream voltage changes, that will cascade down, otherwise the whole thing remains static. That's more performant, but it's leading to some issues where if one of the many links in the daisy chain does something out of sequence, then the fact something's changed beforehand is lost. So you've lost that update. And we have this problem on the Magellan where sometimes if the loading screen has a very low frame rate, then the electrical system doesn't initialize properly. So when you start the game, the reactor's offline. And you try and go to FTL and you can't. The lights might be on because it might have charged the batteries briefly, but then yeah, there's no running reactor. So to stop that from happening, if all of the systems are constantly updating once per second, then anything that happens out of sequence will automatically be corrected a second later, which means the whole thing's a lot more robust. It is worse on performance because obviously they're all, well, not everything is ticking once per second, only the boxes are ticking once per second, but it does mean that once per second there is a run of cables that are just passing the message along from cable to cable, once per tick per cable. So yeah, on that grounds, it is more CPU heavy. But if it's self-fixing and easier to manage, then we've got enough CPU budget right now to be able to run with it and see. We're very much GPU heavy, not CPU heavy. So we've got that freedom right now. Let's just fix. Yeah, ultimately we could stick each one on a separate thread, and obviously until we convert it all to C++, that's not really possible from blueprints. But yes, once it's running in C++, we can stick it on a background thread. Let's just work out which cable we're supposed to be using here. Cable 1. Okay, so that's using cable 1. So we'll give that one cable 1. And that can use cable 1. That'll stop those errors coming up. So the only error we are actually interested in is the aggregator. So neither of them are picking up anything on interface 1. Okay. So those two are plugged in, and interface 1 is not plugged in on either of them. So they shouldn't actually be checking interface 1. That's not going to help us because that's the old distributor master. We want the tickable version. So interface 1 plugged in. Yeah, so we're definitely setting that to false. So it definitely should not be attempting to find a cable. So is that being overridden somewhere? Is it the cold and dark stuffs? Yeah, it is. Yeah, okay. So we have, for each distribution box, we have a cold and dark setup, so we know what's enabled and what isn't. So we need to make sure that, because we're only testing this right now, we need to make sure just those two are connected. That's probably what's messing it up. So A is plugged in, B is plugged in. But cold or dark or not, it still shouldn't be doing this. That is weird. So interface 1 out, and I haven't got. Hang on, is it saying in or out? Because really, these need renaming to like ABC. Where's one gone? There it is. To help my sanity, I always had the inputs as alphabet and outputs as numerals. Yeah, Madman, once everything is like polished and working and we're happy with it all, then yeah, then the next step is for performance reasons. We can then start migrating stuff to C++. So it's only complaining about A and not B. So hang on then. So where is... Ah, right. That's not going to help, is it, if it's up there? So B, C, D. So are those... Oh. Yeah, so basically we're trying to overlap we've got multiple interfaces with the same name. That doesn't help. Does that mean... Oh, I see. Right, so the aggregator yeah, has its own interfaces which are separate, so they shouldn't be there anyway, just to confuse everything. So none of those should be there because they're all coming from the parent blueprint. Right, that makes more sense. Right, so the input locations that we're setting here are wrong, basically, and they are there for visual reasons, not actual proper connectivity reasons. Hence the confusion. Because now that we're overlapping things properly for connectivity, things need to move around a bit. Okay. We should be able to just copy that over as is. Right. Mystery solved, I think. Yeah, in 5.6, Epic added a way of generating the C++ headers from a given blueprint, so it kind of does half of the job for you, at least in terms of the headers. But yeah, then you do need to reconstruct everything in blueprint in C++, but worth it. Okay, so we have voltage there, the aggregators are now on. Great. So the next step from here is working out how we want those aggregators to distribute the voltage out of the battery room and down this stairwell so that it's all going to the right place. We definitely need breakout boxes on each level of the stairwell, so we're going to have like a distribution box there, we'll have another one over here, and that's going to be per deck. So the main engineering stairwell here is kind of the electrical distribution column. But yeah, I know it seems like a lot of fluff so far, but this is just because we're converting over to a slightly different way of doing things, and ultimately this is so much easier than having to manually type in the name of every interface to make sure that things connect. Being able to just do an overlap check is just so much easier for deploying the electrical system. And once it's all working smoothly on the Caravella, then we will do the same for the Magellan. At which point it will all be working already, so it's just a case of doing the deployment then. Because as much as the Magellan has its cables, right now they are just literally a small length of cable that's not connected to anything. So in order to deploy it physically, we need to make sure that we roll it all out. Basically redstone, yeah. Redstone with distributors and various other bits. Thank you, Firstus. Very much appreciated. Yeah, so the next step from here is the box between this and the lighting. So I think on the next Sunday stream, we should get to the point where we're powering lights from the battery arrays, which will be nice. And then we can definitely nail down exactly where the cabling is going. Yeah. We're just going to have to go one step at a time through the electrical system, just making sure we cover every single step in turn. But yeah, right now, obviously it is working because we've got stuff happening. I guess the only bit which is going to be confusing to sort out is where we've got multiple outputs from the battery arrays going into a single aggregator. Like, how does it know which one of these two battery arrays that came from? So when it's passing its wattage report back up the cable to the battery array, because on here, on the UI, obviously we are like dealing with our loads. Now right now the live load you're seeing is just the screen, so that's just the UI taking up some of that voltage. And that'll be the UI on this basically. but we pass that all the way down the line. So it's about knowing which interface connects to what box at the other end. So as much as we are just passing voltage and just daisy chaining voltage signals down the cables, we don't at that point know what the usage is. So as much as we've got the voltage there, in order to work out the amperage, we need to know the wattage. So we need to pass the wattage backwards through the network, working out amperages as we go. So that's kind of the next trick in the puzzle. And the reason it works on the Magellan is because every single cable on the Magellan has manually written in it which box to connect to. So because we're doing away with manually writing that down, and again, the reason for that is, one, it makes it roll out easier, but two, it makes modularity easier in the future. So if we're making modular ships and we're just bolting like prefab pieces together, as long as those cables connect, everything should work. And we need to find that solution of identifying upstream boxes in order to do the wattage reports. But that's a challenge for future Dan and a future stream, I think. But yeah, so we'll leave it there for now. We've got our aggregators turning on, so that's some bit of progress at least. I don't know what either of those are, Madman, so I'll have to look it up. And yes, this is Unreal Engine. Right, so that's me done for today. What day is it? Sunday. So yes, we're back on Wednesday for more Magellan class fun. And we'll probably do more of the task system on Wednesday. And we'll look at seeing if we can get some of those Magellan class job boards done. And see if we can start getting the NPCs carrying stuff from the probe room and putting it on shelves. That could be quite cool if we can get that far. But yeah, so more fun to come in the week. Have a great week ahead, everyone, and I shall see you then. Bye for now. Oh, forgot to press escape, as always. Cheerio.